you love physics for ordinary secondary education, and then possibly you've been asking yourself, how can you learn the topic of wave? How are you, everybody? I think those are few of the many questions that are going on in the mind of the student. I would like to take this opportunity to welcome all the national and international students into this fantastic moment where that we are going to pass a good news to all the online ordinary secondary educations who are going to take advantage of this program. My name is Olenjolai, Moko TAYAI Losingo. Simply can call me Olenjolai. I thank God by his own gifting, he just called me in the area of science, and he gave me a gift in the area of science. It means he gave me a gift and his spirit to understand the beauty of science. And I thank God also by his own grace, he gave me, or he built a gift of teaching in my heart. So always I have a responsibility to teach others about what God has taught me in different aspects of my own life. So what you have to expect in this video from the beginning to the end, you have to expect that I'm going to stand in the positions of a teacher. It doesn't mean that I'm a very necessary teacher more than others that you've been met with. I cannot talk about other teachers, but for myself, I can talk a little bit that I'm a teacher who is really passionate in teaching and passing the knowledge from my mind to my students' mind, and to be using the digital technology as one of the methodology to transmit the message for myself as a transmitter to the receiver. So I don't know everything about physics for ordinary secondary educations. I know a small portion, but I have a responsibility to teach others about what I know. I'm a Tanzanian, and this is our national flag. I would like to welcome all the international viewers to visit the country where I'm living and to meet with the presence of God. So feel comfortable, feel happy. If you are a registered student into also, you're warmly welcome. I would like to take this opportunity also to welcome all unregistered new ordinary secondary students, or we call them sometimes we call grade 8 to grade 11 students. You're warmly welcome into this fantastic moment. So I'd like to take this opportunity to welcome you into one of our online school. Excuse me, so there are some minor errors here that you have to I have to correct him. So the online school is not advanced, so excuse me, this is just the information for the previous session. So I will take the opportunity to welcome you into Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So there's no M. This is the name for our other advanced secondary school. I would like also take this opportunity to welcome you into one of our official YouTube channel that's called the Tanzania Online O Level, not A Level. This is another channel. So in case you know somebody who is in A Level, you can share the previous information. So it's called this, so the name of our official YouTube channel is called Tanzania Online O Level Second School in square bracket Olenjolai. So there's no this letter M. So do that minor corrections in case that you have written, and then you have to write these informations because are very important. Sometimes I know some students, they can get tired that I'm writing this information over and over. Yeah, just write. Because of ourselves, we don't get tired to write it because we know that learning is a process. So because it's a process, sometimes you can do crazy things in your mind, but that's how knowledge is being transferred from the transmitter to the receiver. So well, you can ask yourself so many questions about our online. So the name implicate the name Tanzania, so we are going to focus, we're going to teach the contents with our universal. It means that every student worldwide can learn, but you'll be focusing on the syllabus of United Republic of Tanzania. And for example, that today we are teaching the subject called the physics, and in my hands I have this book. It's called the Physics Syllabus for Ordinary Secondary Education from 1 to Form 4. This is a guidance, it's a boundaries, it's very important. I recommend to all my students. And in case that you cannot find it, just visit our Tanzania Online Ordinary Library. You can access, and you can buy this book, and then we can send to you, or you can transmit it to any regions among 31 regions, and even other textbooks that you need in order for you to master physics, chemistry, and basic mathematics. So you can. So one of the questions which might be going on in your mind right now: what divisions of Tanzania Online Ordinary Secondary School? So the second point is the names, just as the part at the word of the one word of the names is implications. So it's just stating what online. So we are providing our contents online. So in case that you want to benefit from our programs, you don't have an excuse. You should be an active online student. It means you should be using the internet and the mobile devices or computers or smart TVs or iPads in order to receive our contents. That's the best way that we'll like to recommend to all the students. So it means that it's ordinary. We'll be focusing on the contents for the ordinary secondary school in square bracket Olenjolai. So what division that we have, that the point that I want, that the questions I want to answer. We thank God by His own grace, because vision is God's picture in the minds of the persons, which is not invisible, but it is in mind. So in my mind, the picture that God implanted or just planted in my mind, this is the picture that He which define the visions that we have into also. So we have an assignment to teach and train ordinary secondary students on how they can extract knowledge, understanding, and wisdom from the classroom instruction and combine it to knowledge, understanding, and wisdom from what? From the Word of God, in order to solve small-scale real-life problems. The main objective of Tanzania Online Ordinary Secondary School in square bracket Olenjolai is to teach your students on how you have to think, and you have to think outside of the classroom instruction, and you have to think there are small-scale real-life problems waiting you before even you graduate ordinary secondary education. So that's the vision that we have, and that's the main objective of the also. So we have so many specific objectives which possibly in your mind might be your main objective or your vision. And I know in the mind of the students, you are real focused on preparing yourself for exam. Those are our specific objectives. It's not our main objective. So what I want to tell you that in the Tanzania Online Ordinary Secondary School in square bracket July, we have a plan to go extraordinary to what other present or other physical and even online ordinary secondary school on focusing on training our students how they can solve real life problems and giving them challenge. Wonderful. So that is at least I could say that it is enough. So before we go into the today's sessions, I'll take this opportunity also to welcome you into what I'd like to welcome you for the registered students. You can skip this stage, but you can take advantage to listen once again. But for the new students, just to follow the following few steps for you to register yourself permanently and being an active student of TOSO. TOSO actually is abbreviations of Tanzania Online Ordinary Secondary School in square bracket Olenjolai. So the first step, if you don't have an email, we ask you to create or open a new email. And that's how can you open a new email? Just go to Google and then ask that question. We ask you again to sign in YouTube by using your email you have created, means by using your password and the username. And then we ask you to search also. Don't search to also, just search this name, Tanzania Online or Level Secondary School in square bracket Olenjolai. And then from there, we say that in the mobile phones, when you search this name in YouTube application, then in mobile phones, you will see a flag. It means that round buttons like this one and descriptions below. In PC or MacBook or desktop computers, you will see just a round buttons with the Tanzania national flag, and the descriptions is on its right hand side. So this is the national flag. So you see our national flag, and this we call it to also posters, welcoming poster. So we ask you the first step that click the Tanzania national flag. Click that round button. So when you click, then you'll be taken inside the TOSO school. So if that's the case, then you will see the horizontal toolbar written homes, videos, playlist, community channel, and what and about. We'll come back later into this horizontal toolbar. It's very important for you to take advantage of our information. So now, how can you register yourself? Because you've been asking yourself. It means check the buttons written subscribe. Okay, it's red, its background is red and text is white. And then click it, and then the text will change into subscribe. Once you do that, then the icon of the bell will appear, and then we say that the options of all. You'll be given 3 options. So we ask you to click this. Once you click, the icons of bell will appear. Click this icon of the bell. Once you'll be prompted with 3 options, and then we ask you that you choose the options of all. From there, you'll receive all our all the notifications from the YouTube community once we add a new video. Wonderful. So we have a vision to record more than 600 videos. So this is just the session 6 of WAVE. So we are expecting to record more than 15, almost about 15 sessions or videos or 40 of WAVEs. So it means if you met with this one, you have to expect it that, or you have to know that there are session 7, session 8, session 9, session 10, session 11, etc., etc. So it means if you want to get notification, that's one of the process. Thank you very much so do that process right now, because you might forget, and then you might be away from the class while we need you to register yourself permanently. Thank you for subscribing. Now, in order for you to take advantage of our contents, we ask you to come into this horizontal toolbar, which reads Homes, Videos, Playlist, Community, Channel, and About. Click the soft buttons written Playlist, and then find the playlist written Waves. There, you'll find collections of all the sessions about waves, from the first session to the last session. So it means you'll find the sequential order, the systematic order of this session. For example, we have already published session 0 to session 5 out of wave. So if you visited this playlist right now, today when you are watching this program, okay? So it means before we added session 7, you'll find those the past 60 sessions in good arrangement. Again, I know that you'll enjoy our contents. For you to share the contents with your friends, then you can check the icons there written share. That once you click it, the YouTube will give you the video link, so you can share with your friends through any social media that we can reach with them, because we want to reach millions of the students. So, welcome into departments of physics. The subject of the day is going to be physics, and then this contents is for the pre-form 4 or form 4 or grade 11. Okay, grade 11, not grade 12. Grade 11 students, tutor students, reciters, and teachers who are teaching physics. And then this is session 6. I'm going to teach about types of mechanical waves. In previous session, I told you about it has been types of waves. This is types of mechanical waves. Previous session, it means session 5, is types of waves. Don't confuse. Again, I know many students, they ask yourself, why teacher Olenjolai, or why my teacher is wearing this white dress? Wonderful. You know, this is a science subject, and science subject, you have to learn theoretic. It consists of theory and practical, right? So because it consists of 2 things, so it means that in practical, when we go into science labs or physics lab, we have to wear the overcoat, the white overcoat. That is international. We call it just international system of dressing in physics laboratory. So myself, I wanted to implement this picture in my dressing, for you to know that you have an asset. One day you'll be a great physicist of this present and future world. So tell your neighbor. Okay. So let us go into today's session. So let me start with a quick review of session 5, which has been, so remember that this one is titled, so session 5 is titled as what? It is titled as what? Types of waves. So you can search it right now. So in this session, first of all, we say that we have, we mentioned the 2 types of waves. If you are learning fundamental physics, and these are what? So it's electromagnetic wave. This is the short, and mechanical waves. So mechanical waves. And then the next step, we say that if you are learning advanced physics, you can categorize. It means you can find 3 types of waves. So the first 2 waves, the first 2 types, and then plus what? Some we call the quantum physics. Okay. Quantum waves, but the 3rd type. But this will cover it in advanced and even it means in university physics. Again, we define what the means of electromagnetic waves. Simply say that electromagnetic waves consist of electric field and what? Magnetic field, and this they can travel in the presence of media or in the absence of what? Of media. The simple definition. I taught you 2 two definitions. I gave you two definitions to choose one. I gave you 7 examples, which are also, we call them types of electromagnetic waves, because later on we'll teach us a topic called the electromagnetic spectrum. 7 examples of electromagnetic waves. And I mentioned from radio wave to X-rays. Radio waves we are using telecommunication, and X-rays are used in hospital. Then, my dear students, I told you about how we define mechanical waves. Okay, how we define mechanical waves. So how we define mechanical waves? So we say mechanical wave, first of all, they don't consist of electric and magnetic field, but these we say that these are the waves in which oscillation disturbance takes place in the presence of media. So that's how we define. So it means that it's a type of waves in which the energy, so remember that also there's energy transfer and even here energy transfer. So it's a type of the wave which carrying energy from one point to another point in the presence of medium of transmission. And I gave you an example of medium, it's air. Then I mentioned the 5, if I'm not mistaken, 5 examples of what? 5 examples of mechanical waves. Okay? Then I mentioned from what? Sound wave, we said string wave, then we have what? Water wave, etc. Seismic waves, etc., etc., etc. So next thing, I think that we ended there. I left the homework, and the homework is this example 6. You enjoyed the beauty of physics? Please tell me in the comment section. Give me feedback. Interact with me in the comment sections of the video below. Okay. So then we have a question. I believe you've done that homework. So I would like to start. So this is the beginnings of session 60. You have to take your exercise book, take your textbook, and then you should have a fresh mind and join me right now when I'm going to build this concept of types of mechanical waves in your mind. Are you ready? Okay, let us go into the business. So we are doing corrections of the homework 5, which is example 60. You have to refer example 60, which are the questions. It has briefly explained at least the 3 differences between electromagnetic waves and mechanical waves. This is the common question. I remember that when I was in Form 2 and in Form 3, I met with these questions as nectar for the Form 2 and nectar also for the Form 4. Okay, so these are the common questions, even just in Americans or Cambridge educational systems of grade 11. It's a common question, because that is how you test the students about their understanding between electromagnetic and mechanical wave. So to answer these questions, I need to use a table, and then here, let me have electromagnetic waves. Say electromagnetic waves. Okay. And then let me separate in the table here. On this side, we have what? Mechanical waves. So you have to do comparison. Okay? So this is the table. So the first step, we say that what is electromagnetic waves? First of all, we say that electromagnetic waves consist electric field. Say with me, electric field. Consist electric field. While mechanical waves do not consist okay, there's not this S, not consisting the electric field. Not consist the electric field. Okay? That's 1. 2, we say that electromagnetic waves, so in short, just you can say that, okay, so but you have to write in, if you're answering exam, you have to write in long. Electromagnetic waves consist magnetic field. I will mention more than 3, but you may choose either. Okay? Any of them. Magnetic field. Okay? While here we say that mechanical waves consist mechanical waves consisting, excuse me again, I added an S, consisting, okay, do not consist, not, do not consist. Mechanical waves do not consist, not consisting magnetic field. Not consisting magnetic field. Okay? Then the third difference. We say that electromagnetic waves travels either in a medium or vacuum. Okay? While here we say that mechanical waves travel only in a medium. So that's the third difference in the medium. Okay? Then the fourth difference, you say that the examples of electromagnetic waves, electromagnetic waves are, well, here we say number 4, examples of what? Examples of mechanical waves. I'm giving you more differences. You may choose either of them of mechanical waves. So please, you can pause the video and copy this information for you, for your young brother, for your children, because this is the generational program. It will benefit present generations and future generations. And it's free. There's no any registration fee, and you should register yourself only once. If you have done it today, then make sure that you don't deregister yourself, right? Just to keep enjoying the beauty of physics, chemistry for ordinary secondary education. Okay, so if that's the fact, ladies and gentlemen, let me remember the examples I taught you in session 5 of what? About 30 mechanical and the electromagnetic waves. So it means that on the mechanical, so this is all about electromagnetic waves. It's a continuation, electromagnetic waves, and then, okay, here we have what? Magnetic waves. Mechanical waves, excuse me. We have what? Mechanical waves. So examples now of electromagnetic waves. We say we have a radio wave, which we find only in electromagnetic waves. We have also microwaves mentioned. So you can pause the video and write microwaves. We have also infrared electromagnetic waves. Infrared electromagnetic waves. We have also visible electromagnetic waves. We have also ultraviolet, UV, or in short you call it UV electromagnetic waves. We have also gamma rays electromagnetic waves, and finally we have what? X-rays. So we have 7 types of electromagnetic waves. These are the 7 types, and there are 7 examples. For mechanical waves, we have sound wave. Sound wave, it's a wave that you are hearing right now from me, right? Sound wave, human sound, instrumental sound. And also you have what? Spring wave. Spring waves. And also you have what? String wave. There's a difference between spring and string. And in these sessions you'll see a difference between these waves. But also you have what? Another example is called what? Water waves. Another example is what? Seismic waves. If you want to know about seismic waves, this will occur when the earthquake takes place. Then we left it, the other one. So you may see that these 7 examples of electromagnetic waves are different from 5 examples of mechanical waves. So that's the difference. Because I know many students, they used to say that, sir, why are we using examples as a difference? Yes, because the examples of those 2 things that you are comparing are different. So this, you can call it table what? So you can call it, because it was table 5, it was in session 5, so table 5.1. So what the title of this table is a difference between electromagnetic waves and what? And mechanical waves. The mechanical waves. Okay? So that's the case. If you understood, check the correction, check your solution. If you made it, let me congratulate you. Congratulations, may God bless you, and keep it up. So, ladies and gentlemen, let us focus on the title of today's session. And today's session has been titled as what? Types of mechanical waves. Types of mechanical waves. Say with me, types of mechanical waves. So, means say yourself, I'm learning types of mechanical waves. Okay. So we say that to focus that concept, let us start with the first concept we call it. So because it's session 6 is of 6.1, we call it propagation. What the meaning of the word propagation? Propagation of what? Of waves. This will hear this word in exchange of the word traveling. So propagations of what? Of waves. So we have a fundamental question here. Question 1. What is propagation of what? Of wave. What is propagation of what? Of wave. Okay? So propagation of wave. So say that in propagations of wave propagation, or some references say what is wave propagation. Pause the video and ask yourself that question. Don't worry to do mistake in your process of learning. So we say that wave propagation is any of the ways in which waves travel. Now the simple definition. Wave propagation is any of the ways in which waves travel. So wave propagation means traveling, means that the ways of traveling of the waves. So in other words, if you find that I'm writing quickly or I'm teaching quickly, you can pause the video, you can listen from first column, second column, and third column, then you pause the video before you come back and copy the notes. Okay, because I know the speed of students, some of the students, they cannot understand when they are writing simultaneously. Some of the students, they can do both. And I'll be training you how you have to build the mindset of learning while you are writing. Okay? So in other words, wave propagation is what? Is wave traveling. Okay, wave traveling what? Wave traveling method. Okay, wave traveling method from one point to another point when traveling method, when the wave is carrying what? Is carrying energy. That's the definition of what, and that the concept that you want ordinary secondary education to understand. The concepts of wave propagations, I believe that you can pause a video and copy this note and then you continue. That's the advantage of digital learning. Digital learning, you can even watch this video 3 times. While in physical learning, when you learn a session, then you never being taught again by that teacher, because in the next session you'll be taught the next thing, and you'll be taught another concept while possibly you didn't understand in some concepts in previous. So the good thing of the digital, we have a good story. We store the knowledge. Okay, we store the knowledge, and you can come back to remind yourself at any time and anywhere. That is the power of digital technology. Okay, so it means that it is concept of wave propagations. That's what we'll be discussing continuously. So right now, ladies and gentlemen, allow me to teach you about types of mechanical waves. Types of what? Of mechanical waves. Write it. Types of mechanical waves. Okay, so we say that types of mechanical waves. So we can have another fundamental question in most of the past papers. NECTA past paper, mock exams, or mock exam. This will be our second fundamental question. Mention 2 types of what? Of mechanical waves. Mechanical waves. And you find that these 2 mechanical waves, we categorize them according to the way of propagation. Good. So mention 2 types of what? Of mechanical waves. So we say that in fundamental physics, the one we are teaching ordinary secondary education, fundamental physics, there are 2 types of mechanical waves. These are namely, the first one, we call it longitudinal, so it's called longitudinal. This is T. Longitudinal wave, or longitudinal mechanical waves. Okay, then the second one, we call it transverse. Transverse, say with me, transverse mechanical waves. Transverse mechanical waves in potency words. Okay? So, but in advanced physics, we have also another type of waves we call the surface or sea waves. Okay? So you say that in advanced physics, there is the third type of what? Of mechanical waves. The third type of mechanical wave, which is what? Which is surface, or we call it sea waves. But this is beyond the present syllabus of ordinary secondary education. So we have to teach our students about longitudinal waves and the transverse wave. Another thing again you have to note, electromagnetic waves, all the electromagnetic waves, all the 7 electromagnetic waves, from radio waves to X-rays, they are transverse waves. So not that, before we go. Not this. I'm not sure, but in my journey of learning physics for more than 20 years, yes, for more than 20 years, I've never found longitudinal electromagnetic waves, but I have found transverse mechanical waves, electromagnetic waves. So say that in all 7 electromagnetic waves are what? Are transverse. Are transverse of the waves. Okay. So the next question that comes in the mind of my student is, what's the meaning of longitudinal? Olenjolai. Wait a moment, what's the meaning of longitudinal? So that was 6.1, this will be 6.2. The second concept. So let us go into the third concept, which is 60.3. This is just leveling. And then right now, ladies and gentlemen, let me teach you about the longitudinal waves. Stay with me, longitudinal waves. Say longitudinal waves. So when you say longitudinal waves, you have to make sure that you don't confuse this concept with longitude in geography. Okay? So this is longitudinal. Longitudinal is not longitude. Those are the 2 different ways. And the way of pronouncing, even the grammar is quite different. So we have a third fundamental question here. And it is, what is longitudinal wave? Okay? So what is longitudinal wave? What is longitudinal wave? Are there questions you have on this board? Okay, you can pause the video and ask yourself, what is longitudinal wave? Can you rephrase something? Can you relate with something? Okay? So you have to try. I will be teaching you by the method we call the active learning. So you can pause the video and ask yourself and try to answer that question. And then you come back to check the right solution. So what is longitudinal wave? So my dear students, myself as Sir Olenjolai, I've prepared it, or I've found so many definitions of longitudinal waves, but I chose 2, and I would like to teach you right now, and what do they mean. So we say that in physics, the answer this question now, in physics, longitudinal wave, longitudinal wave is a type of what? Of wave in which its vibration vibrations, which means what? Oscillations, okay, oscillations, which is vibration, which means oscillations, okay, are parallel. In which its vibrations or oscillation are parallel. Say parallel. Parallel to what? Parallel to the direction parallel to the direction of what? Parallel to the direction of the wave travel. Of the wave travel. That's the first definition. So let me explain it, because possibly some others will find that this is satisfying their needs. In physics, longitudinal wave is a type of wave. So first of all, it's a type of what? Of wave. Or it's a type of mechanical wave, you may say, in which its vibration, so because waves vibrate or wave oscillates, are parallel to the directions of the wave travel. Parallel to the directions of what? Of wave travel. When I draw the graph of longitudinal waves, a few minutes later, you'll understand the concept. But the thing is, it means if, for example, we have longitudinal waves, and it's traveling from this point, right? Traveling from this point to this point. So it means that we say, in that case, vibrations, or we call it what? So let me just demonstrate to you. So we say that it's a type of wave in which vibrations, so here, for example, this is the, but I think that, suppose that this is the spring. I'll just use this example. You see this one? This is the spring. As most of the spring. This is not a spring actually. Yes, I think that, yes, in the next sessions, I might show you when I'll be teaching about spring. It will be just easier for you to understand. But let me just give you an example. Yeah, I want to give you a practical example because I want my students to understand. So, think about the information I've been sharing with you, and then I'll come to you. Okay? I'll come to you. Come to you, or come to you. Okay? So just to explain, we can use the sound wave. Okay, my voice right now. That's a good example. When I'm speaking to you, I'm producing vibrations. This is the wave. Sound wave is sound, it's a wave. So I'm producing vibrations towards you who is listening my voice. But again, the directions of the wave is towards you. So from there, the vibrations of 40, the vibrations of my body parts, okay, is in the same directions to the directions of the wave traveling. So because right now when I'm speaking, I'm compressing the air between me and you. So that such kind of the compressions is just producing wave. And that wave, the traveling of the wave, direction of the wave is towards you. And also that's the directions of what of the wave, and also direction of the oscillations is parallel. So it's just like this way. Okay? So I'll use the diagram. So what does it mean? That for example, okay, so I think that let me give you the second example, then I will draw on the graph, then we'll understand. Not worry that this is the home of understanding physics. The second alternative definition of longitudinal wave longitudinal wave is a wave. Is a wave in which the direction of the disturbance, of particles is parallel to the direction of the wave. The direction of what? Of the wave. So longitudinal wave is the wave in which the direction of the disturbance, or oscillations, or vibrations. Okay? So disturbance of the particles is parallel to the direction of the wave. So direction of the disturbance of the particles that will experience the disturbance, their directions is the same direction, so the direction of 40 of the wave. Okay. So before I give you examples of the wave, because I know you didn't understand what we mean, let me teach you 6.31, and this is graph of what? Graph of longitudinal waves. Graphs of longitudinal wave. Graphs of longitudinal wave. Okay? So let me use the graph to interpret the two definitions of that I gave you, which are the same definition, but just a different way of arranging the weights. So let me use the graph. So graph of longitudinal waves. So the graph of longitudinal waves, we say that, suppose that here we have this graph. So this is displacement, vertical displacement, and then here we have what? Horizontal displacement. Okay, so here it is. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So somewhere here. So we have the amplitude. This is amplitude, or dot lines for the amplitude of the waves. So remember the previous figure also told you in previous sessions about the pressure of the wave. This vertical display axis usually represented displacement of the wave. Displacement of the wave, it can be maybe y displacement or x displacement, depend. And this horizontal axis representing what? Time of the wave. So suppose that this is 0. So you have a wave with particular amplitude, and also you have a wave with particular amplitude, and then this is another amplitude, let's say to here. So remember that this is amplitude. You have an amplitude there, have an maximum displacement of 14 of the wave. So listen carefully. So this wave, if it is longitudinal waves, then the direction of propagation, because I don't want just it, because remember that we said that here we used to have what wavelengths, we have frequency, etc. I don't want to repeat about the previous concept. So these are the directions of the wave. Direction of 40 of oscillation. Oscillation of what? Oscillation of wave. Oscillations of wave. So direction of oscillation of 40, oscillation of wave. Direction of oscillation of waves. So suppose that this is point A and this is point B. So the wave is traveling from point A, for example, towards infinite, but suppose that towards point B. So this is called directions of oscillations of 40 of wave. And then according to the definition, we say that This is the type of the wave in which vibrations of the particle or vibration of the particle are parallel to the directions of the wave travel. Okay, so the directions of the oscillations of the particles. So you say if it is longitudinal waves, then you say that also the direction of directions of the wave travel will be this parallel with directions of the oscillations of the wave. So this is direction of what? Of wave travel. So the wave is traveling from point A to point B, but also the oscillations of the wave is directly from point A to point B. So that the meaning is that we say if this is the directions of oscillation and this is the direction of the wave and this is the directions of the wave travel, right? So we say they are parallel. That's the meaning. So that's if this is the condition, then we say that this is what? Longitudinal waves. So this will be what? Figure 6.1. So the figure above presents what? Longitudinal wave. Do you have any question about longitudinal wave, about definition of longitudinal wave? Please don't hesitate, ask in the comment section below there. Ask it there. I used to read the comment section. I'm waiting your questions. And I want your feedback if you understand. So if that's the case, again in longitudinal waves, we have two regions. Okay? So you say that in longitudinal waves have two regions. Okay, two regions. Namely what? The first one is compression. Say compression. So we call it compressions of longitudinal waves. And also the second region is called the rarefaction. Say with me, rarefaction. So we have compression and the rarefaction. Okay. So you have what? So you have compression and rarefaction wave. So now you have the next concept. This is 6.32. We want to understand the meaning of compression. Compression of longitudinal wave. Compression of longitudinal wave. Compressions of longitudinal wave. So we can have another fundamental question, which will be the first question in this session. And the question is, what are the compression of longitudinal wave? That's the question we have. So what the meaning of compression? What are the compressions, plural, compressions of longitudinal waves? Compressions of, it means a single longitudinal waves, it has so many compressions. That's why you say that compressions of longitudinal waves. So I found simple definition for every student. Are you ready? So here it is, the simple. Here it is. So compressions are so what are the compressions of longitudinal? Compressions are the regions of high pressures. So the regions of high pressure due to the regions of high pressure due to the particles being close to the particles of the waves. Compressions are the regions of high pressure with the particles of the wave being close to each other. That means it's the regions of high pressure. Are the simple definitions of compressions. Compressions are the regions. Anatomy. Compressions are what? Are the regions. And these regions are the regions of what? As the regions of high pressure. These are the regions which have high pressure due to the particles of the wave being close to each other. Aha. So if the two particles or 3 or 4 particles of longitudinal waves are close to each other, that regions in physics, we call it what? Compression. By regions we call it what? Compression. Okay? So that's the definitions of what? Of compression. So close to each other or close together. That's how. So it means that let me just give you the general definitions of what? I didn't give you examples of longitudinal waves. Okay, so let me teach about compression and the compressions and the refraction. Then I'll give you examples of of waves. So before I show you compressions of longitudinal waves, or which are regions of high pressure, let me teach you the second regions, which is called the rarefaction. Then I will use the single diagram in order to show you, or I'll be using the single diagrams in order to show you compressions of the longitudinal waves and the rarefaction of the longitudinal waves. Are you ready for that? Do you understand what am I teaching you? Please give me the answer that questions in the comment section. Tell me you're enjoying this content from which school. Tell me you're enjoying this content from which regions, from which city of Tanzania. Tell me in the comment section you're enjoying this content from which country, right? From which ward, from which village in Tanzania. So tell me from the northern zone or southern zones or which regions, okay? So we have so we said that 60-20 Then, my dear students, let me teach you about rarefaction. Even in this wave, or in figure 6.1, we have compressions and the rarefaction, but I skipped that until I teach you. So we say that we have what? We have rarefactions of longitudinal waves. Rarefaction of longitudinal waves. Rarefaction of longitudinal waves. So we have a question here. So a question, this is question 5. What is the meaning of rarefaction? Rarefaction of what? Of waves. Rarefactions of waves. So rarefactions of waves, we say that these are the regions of the low pressures. Okay? Of the low pressures. These are the regions of the low pressure due to particles being far from each other. Due to particle being far. So it means in a refraction, particles are far from each other. Being far from each other. From each other. So it means the particles are not closer. These are the regions of what? Regions of low. So I'm trying to underline the keywords. These are the regions of low pressures due to particles, plural particles, being far from what? From each other. So in a refraction, for example, if you have two particles in compressions, if you have two particles are closer like this one. In the refractions, if you have two particles are far in this way. That's the meaning of refraction and compression. Okay. If you have understood the definitions of the meaning of longitudinal waves, the meaning of compression, the meaning of refraction, and the meaning. So right now, let me use the diagram to show those two regions. Then I'll go back. I will just make this diagram so it's fidelity 6.1. Okay? So we say the diagram of what? Diagram of compression. Diagram of compression and the refractions of what? Of waves. Refractions of waves. So how do we draw? So let us take example of sound waves. So you find the first region is what? Compression. Then we have another region which is called refraction. Then we have what? Compression region. So here compression region, compression region. That is compression. We have what? A refraction. A refraction. A refraction. A refraction. Okay? So then we have what? Then compression. Then I have compression again. Then I have compression. Okay? So we have a refraction. So this repeat over and over. Okay? So this way, and this one, and this one, we call them what? Compressions. Compressions of what? Of longitudinal wave. Okay? And then here we have what? This guy and this one, and this one, call them what? Refraction of longitudinal wave. So this, we call it a figure 60.2. Everything is clear. So remember it is longitudinal waves. So we have here what? Direction of what? Direction of travel. Travel of wave. Travel of who? Wave. And then here we have what? So this is direction of what? Direction of oscillation. Oscillations of what? Oscillations of particles. So that remains of what? Longitudinal waves. So this is figure 60.2, which means what? Compressions and the refraction, compression and the refraction longitudinal of what? Of longitudinal wave. Okay. So before now, let me relate figure 60.2 and figure 80 and figure 6.1. So these positive half cycles are what representing what? This one, this positive half cycle, and this positive half cycle. All the positive half cycles representing what? Regions of high pressure. This is representing what? Compression. Then these half cycles are the negative side of the order of the displacement, or its negative displacement. This we call them short fraction of longitudinal waves. So now, when you draw these kinds of diagrams, this is the way that each sound wave travels. So whether you use these diagrams or these diagrams, you know where you can, or you know how you can identify the refraction and rotting and the compression. Wonderful. So if that's the case, copy this one, add that past piece of information. I want to clean it in order to teach you the last part of longitudinal waves, which you call it examples, real life examples of longitudinal waves. What are the real life examples of longitudinal waves? And the next concept, which will be 6.3 and 3, and afterwards, I will teach you about transverse waves, and it will be the end of session 60. And I invite you to join me in session 7. But in order for you to get official notification from the YouTube community, don't forget to subscribe. Subscribe right now. Subscribe onto our YouTube channel. That's called TANZANIA Online O-Level Safety School. In square bracket Olenjolai. Okay. So if that's the case, we have 60.34. So now, ladies and gentlemen, let me present to you examples of longitudinal wave. If I give you examples, you know in your mind what the meaning of longitudinal waves. So examples of longitudinal mechanical waves. Mechanical waves. Okay, so you should not expect electromagnetic waves here. So this might be a question. This will be what? Question 5 for this session. Okay? So mention, please tell me. Mention at least 4 examples. 4 examples of longitudinal waves. For examples, at least 4 examples of what? Longitudinal waves. Okay? So you say the following are some examples of what? Of longitudinal waves. The first one, because I've arranged them, sound wave, like there, this is sound wave, remember. Okay, sound wave. Sound wave. And then the second example is ultrasonic waves. We write clear because some students can confuse the spelling of sound. Why it is clear? Sound wave. Then you have what? Ultrasonic. Ultrasonic what? Wave. And another example is a simic P wave. The simic P wave, P stands for primary. The simic primary wave. The first example is spring wave. Spring wave. Then the fifth example is what? Water pushed horizontally. Water pushed horizontally. Water pushed horizontally. So simply called it sideways push. Sideways what? Push. And a good example of this one is ocean tides. I mean that I don't remember well this terminology in English, but kujana kupo kwa bahari. So when, for example, water we could just record at the boundaries of the ocean or sea, just during the morning, just it is oscillating and actually moving away from its we call it sea banks or sea walls. Okay, so and then during the evening, then is slightly pushed horizontally. So such kind of the motion of water waves is longitudinal. But also we have transverse water waves. That's why I say that sideways push. So ladies and gentlemen, those are the 5 examples of transverse wave. Of longitudinal waves. You may find more than those 5 examples. Right now, if you have any question about longitudinal waves, don't hesitate to ask in the comment section. Let me teach you about the transverse wave. Let me teach you about transverse wave. And then after teaching you the transverse wave, I will leave homework 6 and it will be the end of the session. So the remaining concept is on the transverse wave. And in transverse wave, I have to teach you transverse waves, the graph of the transverse wave, and examples of transverse waves. Then we are done. Right? But we are done with so many important information in your mind. Okay, so we have again, right now, this is 60.4. So 6.4, it is called the transverse wave. Say with me, transverse wave. But transverse mechanical. Okay, so let's talk about transverse waves in general, because even transverse electromagnetic waves have the same principle and same concept like what we are going to teach you. So my dear students, say again transverse wave, because you remember one of the technique we used to plant this concept or to build this concept in the mind of our students is by asking them to pronounce the terminology over and over, because through such kind of powerful pronunciation and frequent pronunciation, that new concept or new vocabulary is built in the mind. That the same process even God used to teach me about this stuff, because all of these contents that I'm teaching you, I learned formally, missing school, they taught me less than 50%. So the remaining 50%, I taught myself, and the teacher is God, who have created me and called me to be a teacher and put his visions in teaching. So he has a responsibility to teach me the way that I have to teach his people, right? So that's why I would like to say in advance, please don't give the glory for this week to me. Give all the glory and praise to my God, who lives forever Almighty God, the Holy God. He loves me and He loves you. Give Him all the glory and praise because He deserves. He's the one who is working to you through me. He is inside me, so He's working. He's God, is my God, in Jesus Christ, who is teaching you. He's inside me, but He's teaching you right now. Okay, so we have 6.4, it's called the Transverse Wave. So, you know the fundamental question for Olenjolai? Then we formulate the 60 question. What is transverse wave? What is transverse wave? What is transverse wave? Pause the video and then start to think. If that is all about mechanical waves, how about transverse wave? Okay? So you say the transverse wave I found two definitions. Is a wave, okay, is a wave whose oscillations or vibrations are perpendicular to the directions of the wave. The directions of the wave or the wave's advance, to directions of the wave travel. That's the definition. So transverse wave is a wave whose oscillations or vibrations are perpendicular to the direction of wave travel. Transverse wave is a wave whose oscillations or vibrations are perpendicular to the direction of the wave travel. So while longitudinal waves, the directions of vibrations is parallel to the directions of the wave travel. So this is a little bit different. That's one of the definition. Usually, I used to give my students at least more than one definition so that you may choose one which is suitable for you. Or, in other words, transverse wave is a wave in which medium, so we are talking about mechanical wave, vibrates. So medium vibrates at right angles to the direction of its propagation. Of its sorting, of its propagation. So transverse wave is a wave whose oscillations or vibrations are perpendicular to the directions of the wave travel. Or transverse wave is the wave in which medium vibrate at right angles to the directions of its sorting, of its propagation. That's the answer. Transverse wave is a wave whose oscillations or vibrations are perpendicular to the directions of the wave travel. Or transverse wave is a wave in which medium, if it is traveling in medium, vibrates at right angles like down mechanical waves to the directions of what? Of HC propagation. Okay? So this is the definitions of what? Of transverse wave. Okay. So before this is 6.241. Let me teach you graph of what? Graph of transverse graph of transverse wave. Okay? So graph of transverse wave. So we say that consider figure 6.3 below. I think you finished it to write to copy. If you didn't finish, please pause the video and then finish to copy. So let me teach you the graph. Then I'll mention these 4 examples of transverse wave, and then to be the end of session 6. And I will invite you to join me in next session, which is session 7, and I'll teach you about behavior of the waves. Okay? So right now, we draw that graph. So this is what? So 5 to 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So let me choose here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here, so this is 12. So remember that this is what? Displacement of the wave. Displacement of what? Of wave. Okay. So this is time. Then this is 0. So we have a wave like this. This trough and lottie. This is called the trough, crest. Crest. Okay. So similarly, we have amplitudes. And also here we have an amplitude. Okay? So then here we have what? Direction. Direction of what? Of wave travel. Direction of wave travel. But now the directions of the particle, so the wave travel is traveling horizontally. Let's say from point A to point B. Okay? But now vibrations of the particles, according to the definition, so oscillation vibration of the particle are perpendicular. So the particle of the waves are the one that make this wave pass. So for example, this particle here vibrating perpendicular at right angle. So vibrating perpendicular. And also maybe one particle here vibrating what perpendicular. Then so again we have another particle here. This vibrations is perpendicular to the what? To the wave travel. Okay? So simply you may have this stuff. So even here, these the directions of 40, directions of wave of 40, directions of disturbance. Directions of disturbance. Okay? So here we have directions of disturbance, directions of oscillation, directions of oscillation. Okay? So here also you have what? Direction of oscillation. So it means that you say this one and this presenting what? Direction of what? Of oscillation. Or vibration. Oscillation, sorting, vibration. Okay? So it means that you will find if this is the direction, so it means that simply you can say this is the directions of wave travel. Directions of what? Of wave travel. Okay? And this is the directions of what? Direction of so this is the direction of what? Of oscillation. Or directions of the vibrations of particles. Okay? So you see that these two directions are operating. So this, ladies and gentlemen, makes what? Figure 60.3b. So say that this makes 6.3a and 6.3b. Okay? So this figure 60.3b and this is what? Figure 6.3a. So it's about what? Transverse wave. Okay? Okay, so let me teach you the elastic concept. There are some noises outside of this class that should not interrupt you. Concentrate on the contents and on the contents that I'm teaching you right now. So 60.42 examples of what? Examples of transverse wave. Examples of transverse wave. Examples of transverse waves. So we can have another fundamental question here, which is question number 7. I've mentioned at least what? Mention at least 4 real life examples of what? Of transverse wave. Okay? So the answer of this one, okay? So these are the examples. These are the examples. The first one is called the surface ripple surface ripples on water. Surface ripples on water. Then the second one is called seismically secondary wave. Seismically secondary wave. Then the third one is called what? Electromagnetic. This electromagnetic means radio, microwaves, infrared, X-rays, all of these IoT, etc., are examples supportive of transverse wave. The number 4, vibrations in a guitar string. Vibration in a guitar string. Vibration in a guitar string. Vibration in a guitar string. So you may find number 5, example 6, etc. So, ladies and gentlemen, before I end this session, let me give you the homework and then end this session with practical demonstration of transverse wave. Practical demonstrations of transverse wave. So now, it's a time for homework. And the other questions of homework is practice, homework, or practice 8. And this is homework 6. And this is example 7. The question asks you that with aid, okay? With aid of examples, now, briefly explain at least 5 behavior. 5 behavior. Behavior of waves. List the 5 behavior. At least 4. Behavior of waves. I have a question that you have to answer. If you answer that question, this is a prerequisite. This question is a prerequisite for session 7. So say homework 6 is prerequisite of what? Of session 7. In session 7, I will teach you the concepts of waves. So make sure that you do it and you submit your homework in the comment section, because this is just description, so you can write. You can submit your homework in the comment sections and I can review it. And you can ask questions in the comment section. And this is actually, we say the end, but we still have a demonstration. So we have demo of 40 demonstrations of transverse wave. We are using transverse waves because we say that the main objective of TOOSO is to teach you on solving real-life problems. So we want to take the classroom instructions and just apply into the real-life problems and see how we figure it out. So then, that will be the end of session 1. So the end of session 6. Welcome again. Welcome again in Section 7. Okay. So let me do demonstration for the transverse wave. Are you ready? Get prepared to see the demonstration. Okay, so we say one of the examples of the transverse wave is vibrations in a guitar or in a guitar strings, or vibrations in piano, or vibrations in violin. So this is just a talk example for a guitar. So here, my dear students, I have an acoustic guitar, very important guitar, and actually solve the real life problems of the human being when we want to be healed, because the music can heal. Also the music can encourage, the music can restore hope. So music has different purposes. The music can release power, the music can pass the message to the receivers. Okay? So simply, this is acoustic guitar, and you have the strings, and we want to show you why did we define the transverse waves in such a way. Because the transverse wave is the wave whose vibrations is perpendicular to the vibrations of directions of the wave. So before I produce, so directions of the wave, of this sound wave from the strings of from the guitar, will be moving from this point, you see? So it means that when I'll be plugging this string, so the sound will be traveling horizontally, right? But strumming, when I'll be strumming perpendicular. So for example, so if I do this, so you see that the sound is being transmitted from this point, which we call just the neck of the guitar, to the body. So it means that the directions of the travel of the wave is from the neck to the body of the acoustic guitar, right? But again, so the directions now of the disturbance of vibrations will be perpendicular. So this is perpendicular. So perpendicular. Okay? So for that case, then we can produce what, for example, the G major. Okay, so let us just make a music. Applications of transverse wave. So this is transverse mechanical waves. Transverse mechanical waves. So when somebody asks you, why are you learning wave? Then you can tell him or her, I will apply in producing music worshiping and praising God, right? So I don't want us to keep continuing because I can just, the session can change at all and then we'll be worshiping God. But thank you for that demonstration, that the demonstrations of what of Transverse Wave. So may God bless you. This is the end of session 6. I'd like to invite you to the next session, which is session 7. I'll be get prepared and I'm expecting to meet you with the new students, invite more ordinary secondary students of the Form 4 or Pre-Form 4 students to enjoy these contents in order for them to solve small-scale relief of our own country, Tanzania, and even also some other countries. So may God bless and keep you, but again, I have some couples of announcement. Don't hesitate yourself to visit our Tanzania online ordinary library, where you can access different textbooks, questions, and notes of physics for the Form 1, Form 2, Form 3, and Form 4. And this is just a bunch of the materials that you can order, right? So this is just a bunch of the materials. So this is the departments of ordinary secondary physics. It contains syllabus. So this is the syllabus. Contains syllabus, questions and answers, books, and textbook. And then you'll see the price there. In case you want to order anything, please just send your message through that telephone number, and then so we can save you anywhere at any time. Just send a message, don't make a call. Lastly, in case you feel from your heart that you like to support this work of God, because it's the work of God that impacting all the students of ordinary secondary education, regardless of the year financial, because we are providing this content free of charge. Okay, it doesn't mean that we cannot charge you, but we want every student who has a vision of science and basic mathematics to go far, as God will take him or her, because we need scientists, we need engineers, we need pharmacists, we need doctors who have knowledge, understanding, and wisdom. But you may offer your feeling thanksgiving of any amount through that telephone number. Even 50 Tanzanian shillings is acceptable. Maybe you have your feeling thanksgivings of 100, 500. Those are matters. The issue is your face. You have to offer it by face, right? So you may send it through that telephone number 0759745331. Again, we are not asking you to offer what is Thanksgiving offering. No. In case you feel from your heart, it should be driven, because this is our Thanksgiving free willings offering from Olenjolai to God. So I'm offering this is my offering. So everything I taught you, my time, my resources, the multimedia equipment, it's my offering to God. I'm giving him thanks who chose me and built the teaching in me. So you may do the same. I'm expecting to receive more, because that's the difference between support and offering. So we ask you to offer offering and not the allowances, or just allowances. Don't offer allowances. But again, in case you don't have, God knows that you don't have. And then you're asking yourself questions, what Olenjolai is going to do with my free Thanksgiving? Is he going to maybe to buy cows or buy whatever? No. Your free Thanksgiving will be used to pay the running cost for this program, to make sure that more than 600 videos will be recorded for teaching ordinary secondary students. See you in the next session. This is Olenjolai from Tanzania. Remember to subscribe. Welcome again into Oslo. May God bless you and keep you. Keep enjoying the beauty of physics. Until we meet later.